9 meters long, 10 tons of muscle, and a bite nearly 5 times more powerful than a great white's. These figures sound monstrous enough. But orcas don't just overpower their prey, they hunt in packs, flipping great whites to paralyze them and surgically remove only the liver, so precise that sharks flee entire coastlines for a year. If you think you know how terrifying killer whales can be, you're only scratching the surface. What lies beneath their raw power is a blueprint for predation more calculated and unsettling than anything the ocean's top predators have ever faced. So how deep does the terror really go? Full-grown male orca stretches longer than 2 parked cars, over 9 meters from snout to tail. That's the length of a city bus. But it's not just size that commands respect. 10 metric tons of muscle and bone rocket through the water with a single flick of the tail. In pursuit, an orca can hit burst speeds up to 56 kilometers per hour, faster than almost any other marine mammal, second only to the short-fin pilot whale. A great white shark, by comparison, tops out at about 40 kilometers per hour in short sprints. But orcas don't just catch up, they overtake, outmaneuver, and overwhelm. Their jaws hold another secret. Each tooth, conical and interlocking, measures up to 10 centimeters long, built for gripping, tearing, and crushing. Biomechanical models estimate an adult male orca can deliver a bite force over 19,000 newtons, far beyond what a great white can generate. It's enough to split a sea lion or shatter the ribcage of a whale calf. For prey, there's nowhere to hide. Orcas can ram with the force of a speeding truck, stunning animals many times their own size. In 2019, off the coast of Western Australia, a pod brought down a blue whale calf nearly twice their length, working together with relentless precision. This is raw power, scale, speed, and force that dwarfs nearly everything else in the ocean. But muscle alone doesn't explain why orcas dominate every sea on Earth. The true terror begins when these physical tools are guided by something even more formidable, a mind built for strategy. 3 orcas close in on a great white shark just offshore, moving in tight formation, never more than a body length apart. The lead whale rams the shark's side, using its bulk to stun and disorient. The others circle, scanning for the right moment. With practiced coordination, one seizes the shark's pectoral fin and with a powerful twist, flips the animal upside down. For the shark, this is fatal. Tonic immobility sets in, a paralysis triggered by the sudden inversion. The shark's body goes rigid, gills motionless, unable to fight or even swim. In those silent moments, the orcas work with a precision that borders on surgical. Jaws clamp onto the soft underbelly, tearing a single clean incision. Only the liver is removed, rich in fats, packed with energy, and floating free in the abdominal cavity. The rest of the shark drifts away, untouched but for that missing organ. Necropsies on stranded great whites confirm it. The liver is gone, the rest of the body almost pristine. Marine biologist Dr. John Ellis, who has studied these attacks, describes the aftermath as almost clinical. He notes that telemetry tags on local sharks go silent after an attack, and for the next 12 months, the entire population vanishes from the area. Even survivors abandon their hunting grounds, leaving empty waters behind. The message is unmistakable. Where orcas hunt, even the ocean's most feared predators flee. The terror isn't just in the kill, it's in the knowledge that nowhere is safe, and that the hunters know exactly what they want and how to get it. 40 orcas fan out in a broad arc, each one holding a precise position. The matriarch signals, and the pod surges forward in perfect unison. Their tails beat at exactly 12 times per second, churning the surface into a rolling wall of water. Together, they drive 3-meter waves toward a lone seal perched on an ice floe. The ice buckles, cracks, and finally tips, sending the seal sliding into the open water. Instantly, the group divides. Some block escape routes. Others close in from behind. There's no chaos, only order. Every whale knows its part. Elsewhere, a different pod encircles a school of herring. Up to 50 orcas move in a tightening spiral, blowing curtains of bubbles to trap the fish. Then, in a sudden burst, tails slap the water with enough force to stun dozens of prey at once. The sound echoes through the water, tactical, calculated, and devastating. The pod feasts together, each member sharing in the catch. Innovation isn't rare here, it's routine. In recent years, researchers have watched Antarctic orcas develop a new maneuver. A second, synchronized wave, timed just seconds after the first, doubling the impact and guaranteeing the ice will break. Drone footage captures these operations from above, revealing a level of coordination that rivals military drills. The effect is unmistakable. Alone, an orca is formidable. Together, they become an unstoppable force, reshaping the battlefield with every move. A single orca glides through pitch-black water, hundreds of feet below the surface. Down here, sight is useless. Instead, the whale opens its jaws and unleashes a rapid-fire stream of clicks, each one a burst of sound, peaking between 20 and 60 kilohertz, and reaching volumes over 220 decibels. These are not random noises. Each click is a precisely engineered pulse, rebounding off everything in its path. The echoes return milliseconds later, carrying a three-dimensional map of the world, the shape of a rock, the flutter of a fish, the hollow resonance of a swim bladder. Orcas can detect a single salmon at distances up to 500 feet, even in total darkness. In the North Pacific, resident pods use this sense to track Chinook salmon across a hunting ground that spans more than 15,000 square miles. Their brains decode not only the size and position of each fish, but also subtle differences in the echoes, distinguishing Chinook from dozens of other species by the acoustic signature of their swim bladders. It's a level of discrimination so refined that a pod can ignore every other fish and focus on a single preferred species, day after day, year after year. Scientists have measured these click trains in the wild, using hydrophones and digital tags. Spectral analysis reveals that orcas adjust the frequency and intensity of their clicks depending on the prey and the hunting environment. High-frequency clicks offer sharp detail for close-range targeting. Lower frequencies travel farther when scanning open water. When the hunt begins, the whales ramp up the click rate, closing in with a barrage of sound that leaves no hiding place. This is not just a sense, it's a surveillance system, a biological sonar that turns the ocean's darkness into a field of vision sharper than any human technology. In the arms race of predator and prey, orcas have built an underwater intelligence network that rivals anything the military could design. In the cold waters of the Pacific Northwest, a network of underwater microphones first picked up something unexpected in the 1970s. The recordings didn't just capture random clicks and whistles. They revealed a form of communication with structure, repetition, and, most surprising of all, local accents. Each orca pod used its own set of calls, a dialect as stable as a family name, passed from mother to calf, and unchanged for decades. Dr. John Ford, a young marine biologist at the time, spent years analyzing these patterns. His notebooks, filled with tape logs and spectrograms, tracked the same calls echoing through the water year after year. Some calls, sharp, staccato bursts, carried for miles, while others were soft, high-pitched whistles, barely audible above the background noise. Three main types of vocalizations define orca language. Click trains serve as echolocation, mapping the world in sound. Whistles, which can reach frequencies as high as 75 kilohertz, are used for close-range, private exchanges, often between hunting partners or mothers and calves. Then there are pulsed calls, loud and complex, that hold the pod together over long distances or coordinate group action. What makes these sounds remarkable isn't just their variety, but their consistency. Dr. Ford's hydrophone archives contain calls that haven't changed in over 30 years, a sign that orcas aren't just born with these sounds. They learn them, practice them, and teach them to the next generation. This language is more than noise. It's a learned system, passed down through careful listening and mimicry. Young whales spend years mastering the dialect of their pod, guided by elders who correct and reinforce the proper sounds. The result is a living, evolving code, one that transmits not only identity, but strategy and intent. In the world of orcas, language is power, and every call is a lesson in survival. In the waters off the Pacific Northwest, two orca worlds exist side by side, yet they might as well be different species. Resident pods, some 50 strong, travel familiar coastal routes, feasting almost exclusively on fish. Their lives are shaped by stability and tradition. Transient orca, in contrast, move in small, tight-knit groups, rarely more than 3, covering thousands of kilometers in silence. They hunt seals, porpoises, and whales, relying on stealth so complete they forgo even the faintest click of echolocation. Genetic studies published in recent years show a split between these ecotypes so deep that up to 5% of their genomes no longer overlap, even though their territories cross. The barrier is not distance, it is culture. Residents and transients pass each other in the same sea, but never mix, never share calls, never interbreed. Their dialects remain distinct, unchanged for decades, as if spoken in different languages. Dr. Alejandro Bianchi spent years on the wind-lashed shores of Argentina's Valdez Peninsula, documenting one of the most daring traditions in the animal kingdom. Here, orca have learned to hunt sea lions by riding the surf straight onto the beach, risking stranding themselves in the process. Only 13 out of 30 local orca have mastered this technique, and none did it alone. Calves watch for years as mothers and aunts practice, sometimes using seaweed as a stand-in for living prey. The learning curve is steep, the danger is real. A single miscalculation can leave a whale beached and helpless. Some juveniles never attempt the maneuver, haunted by the risk. But for those who succeed, the reward is access to a rich food source that few competitors can reach. This apprenticeship is not a brief lesson, but a patient, communal investment, an entire pod shaping the skills of its youngest through repetition and example. Culture, not instinct, draws the line between these tribes. What one pod knows, another may never learn. In orca society, the most lethal traditions are not written in DNA, but taught, remembered, and passed down like family secrets. Inside the orca's skull lies a brain that dwarfs nearly every other in the animal kingdom. Weighing between 5.4 and 6.8 kilograms, it's second only to the sperm whale, yet packed into a body half the size. But mass alone doesn't tell the story. The orca's encephalization quotient, a measure of brain size relative to body size, lands at about 2.5. That's higher than any other ocean predator and sits just below the bottlenose dolphin, with humans at the top of the scale. It's the structure, not just the size, that sets the orca apart. The brain's surface is a maze of folds and ridges, a feature called gyrification. More folds mean more cortical surface area, and more room for processing complex information. While humans boast a gyrification index of about 2.2, orcas are estimated to exceed even that, rivaling the most intricately folded brains on Earth. This extreme folding is linked to advanced problem solving and rapid information processing. Estimates suggest the orca's cortex houses around 37 billion neurons. That count puts them in rare company, rivaling primates and far surpassing most other mammals. Each neuron is a potential link in a vast network, one that handles not just movement and sensation, but memory, learning, and even the subtle calculations behind coordinated hunts. The orca's intelligence isn't a trick of perception or a quirk of captivity. It's rooted in biology. A brain built for strategy, innovation, and adaptability. In 2001, Dr. Diana Rice conducted an experiment that would challenge the boundaries of animal consciousness. Two captive orcas were presented with mirrors, each marked with a white ointment on black skin and a dark green spot on white. What happened next was not random curiosity. The orcas paused, angled their bodies to inspect the marks, and began a series of behaviors rarely seen in any other animal. They hovered in front of the glass, blowing streams of bubbles that distorted and clarified their own reflections. They bobbed their heads, turning back and forth to catch different angles, and even stuck out their tongues, an action with no clear social purpose, except perhaps to test whether the image in the mirror would mimic their every move. These reactions went far beyond simple interest. Over repeated trials, the orcas returned to the mirror again and again, focusing on the marked areas. In controlled studies, dolphins and great apes have shown similar responses, but among cetaceans, orcas stand out for the variety and persistence of their self-directed behaviors. Dr. Rice and her team documented that in these tests, orcas performed behaviors directed at the mirror over 80% of the time, a level of engagement that rivals the most self-aware animals on the planet. These observations suggest not just intelligence, but a mind aware of its own existence, a being capable of recognizing itself as separate from others. In the depths of their behavioral repertoire, orcas reveal a consciousness that complicates any simple view of predator and prey. The orca's greatest weapon isn't muscle, speed, or even intelligence, it's culture. Unlike most animals, orcas don't just adapt to their environment. They rewrite the rules of survival through social learning. Each pod passes down hunting techniques, dialects, and traditions that shape every aspect of life, from what they eat to how they raise their young. Over generations, these cultural differences deepen. Resident pods perfect the art of salmon hunting, while transients refine silent strategies for stalking seals and whales. No physical barrier separates them, yet their traditions keep them apart, creating lines as real as any mountain range. Recent genetic studies suggest this cultural separation is driving orcas down different evolutionary paths. In just a few thousand years, an eye blink in evolutionary terms, resident and transient orcas have diverged by as much as 10% per generation in learned behaviors, a pace that rivals some of the fastest examples of cultural diversification in nature. Scientists now predict that, within 20,000 to 30,000 years, these pods may become entirely separate species, not because of geography, but because of the knowledge they choose to share or withhold. The story echoes our own. Just as humans evolved lactose tolerance through dietary customs, orca evolution now follows the currents of culture. Each pod's traditions don't just influence their world, they are actively shaping what orcas will become. Right now, orca culture and intelligence are evolving faster than many ecosystems can adapt. As climate change and human noise disrupt oceans, these predators aren't just surviving, they're innovating. The line between hunter and thinker grows thinner with every generation. Understanding orcas isn't just about awe, it's about realizing we share the planet with minds as restless and unyielding as our own. What does that demand of us?